Hello Algebra, and welcome to one of two videos on inequalities. And we're going to start off with some vocabulary or symbols here. Your learning target today is I can solve inequalities and represent their solutions. And that whole represent thing, we're going to have to figure out how to represent our solutions. So if you take a look at these brackets in less than or equal to symbols, we're going to figure out what they mean and use them as an example. So in this first one, this bracket, the hard edge bracket, it says it means the set includes the number. So if I were to make a set that looked like this, that would mean that I'm including everything from 3 to 10, including 3 and 10. And sometimes it's called 3 to 10 inclusive. You might say it like that. The regular parenthesis looking bracket, if it was like this, 3, 10, this can be confusing because it looks like a coordinate, but in this case it's anywhere, the value is from 3 to 10, but not including 3 or 10. And you can mix and match too. These are examples. So let's say you had hard bracket 3, 10, soft bracket. That would mean it's the numbers 3 through 10, including 3, but not including 10. This happens a lot when we talk about scientific notation. Scientific notation, I don't know if you did anything about it last year, but if you had the number 3.56 times 10 to the 8th, this number right here, we always say it has to be between 1 and 10, but it's not super accurate because it can be 1 and it can be 9.999. It just can't actually be 10. So that's a way that we would use the hard and soft brackets together. It can be 1, but it can't be 10, but it's anything in between. And then the less than and less than or equal to signs, they do very similar things. If I wanted to say that x is anything less than 10, less than or equal to 10, that means it could be anything smaller than 10, including 10. And then very close to that, if I say x is less than 10, that means it can be anything smaller than 10, but just not 10. And usually you can say it out loud, it makes no sense, like 10 is less than 10. That's not true. But 10 is less than or equal to 10. That is true. Another way to represent these symbols is with a graph, a little mini number line graph. So if you take a look at number 1, it's saying that x, the value of x, is bigger than -3, but smaller than or equal to +3. So when I go to graph these, I take my lower number, stick it on one end, my higher number, stick it on the other end. I don't worry so much about trying to make the scale because those are the only two values that matter. And then I say, okay, I gotta kind of shade in or indicate where x lives. And since x is greater than -3, I kind of want to go that way. And it's smaller than or equal to 3, I want to go that way. But that's not the whole story. What about on -3? So on -3, we don't include it. So we put an open circle. On +3, we do include it. So I make my circle, but then I fill it in. So it's like we're closing it off. We're leaving a hole on -3. And then you don't put two arrows facing each other like that. You draw a little line that's thicker than the number line that you started with. So now I'm indicating, it's kind of like where all the darkened parts are. It's dark at 3, it's dark everywhere in between 3 and -3 and 3, but just not -3. Alright, using the brackets, so I start here at -1, I end here at 5. Remember the hard brackets? We include both ends, so we're going to put a darkened circle at both spots, and it's everything in between. Notice where I'm putting my circles. They kind of, imagine if they were rubber balls, they would roll on the line. They're not stuck, like the line doesn't spear them. It's as if you could like flick the ball and it would roll along. That's how you want to write your circles. You don't want them above where they're not touching. You don't want them through the line either. Just like that. And then the last one, -4 to 2. You want open at each end. So, but it's still everything in between. So the open ends because of the because of the soft brackets, but everything in between still. All right, so now there is actual, we can't call them equations, we call them inequalities, where we have to solve for x. Let me move this one up a little bit. These both up, give myself some more room. And there is absolutely nothing different about solving for x in an inequality except for one little thing, and I'll make sure you see it when we get there. All right, so for this one, if we just pretend this was equal sign in our mind, even though it's not, and we're going to solve it just like normal. I keep pausing the video, so if it ever sounds funny, it's because I had to pause so I can sneeze. Okay. And you get x is greater than 2. So that means that this, you don't really do a check with inequality because there are so many answers that would be correct. 1,000,000 is a value for x that is true. 3 is a value for x that were true, and everything in between 3 and 1,000,000, and everything beyond 1,000,000. So there's not really a check you can do, because of that's the way it works. All right, number 2, we're going to subtract 4 from both sides. We get x is less than or equal to 3, and that was it. That's the whole equation. So we're going to try to get some tougher ones now. Oh, I lied. We're not moving on yet because it says express solution in set notation and graphically on the number line. On a number line, or the number line. There's no lines here yet. Or maybe there is, and I just don't see it. No, I didn't draw them in. Okay. So, express a solution in set notation. That means I need brackets. So, x has to be something bigger than 2. So that means 2 is my kind of my lower limit, and I do not include it. Well, there's no upper limit. It can go as far as it wants, so we use the symbol infinity, like that. And we never include infinity because infinity is not a number, it's more of a concept. So that's what that looks like in set notation. On a number line, we're just going to stick 2 right here in the middle. We're going to put an open circle on it because we don't include that 2, but we want to include everything higher than 2, and that would be to the right. And we do an arrow that time. All right, over here, x is less than or equal to 3. For brackets, I need, so 3 now is my upper limit. X can be anything lower than 3. So I'm going to say something comma 3, and I'm going to put a hard bracket in because I want to include 3. And it can be anything less than that. So that's all the way down to negative infinity. And again, not a number, so you just don't include negative infinity. And on a number line, it looks very similar, it just goes the other way. We're going to have it here at 3. Close circle this time, because we do include 3. And then it's anything less than that also. Here's an example of a slightly trickier one. This will be the last example for this video. We're going to distribute first. So again, like I said, just like a regular old equation, we get negative 6x minus 12 is greater than 0. I'm going to move this 12 over to the other side. Get negative 6x is greater than 12. And then here's where you should make a big ol' alert on your notes. Something. When you divide by a negative, and you probably saw this last year at some point, but when you divide by a negative in an inequality, you must switch the sign of switch the direction of your inequality. I'm trying to make it a big deal on your notes. And I end up with x is less than -2. It will not come out right if you leave the sign the other way. It's very easy to forget. So you should just be on high alert. When you see inequalities, you should think, this is the same except for when I divide by negative. It's also when you multiply by -2, it doesn't happen as much. Again, we're going to put it in different notation. So x is less than -2 would be, so -2 is the upper limit. We do not include it, and it can go down to -infinity. So there's interval notation. And then on a graph, here's -2. X can be anything less than but not equal, so leave it empty, like that. Alright, that does it for the first video. I'm going to try to keep the next one a little bit less than this one, but who knows. Alright, good luck. See you in a second.